Good morning or good afternoon, wherever you are in the world. I'm Ian McDonald, and today I'm talking about building a minimum viable response plan. And you can find me later on if you want on Twitter or LinkedIn via IMCDNZL. I work for Microsoft for Startups. I lead the team globally that's a tech team within us that help our premier startups throughout the world. Now, on August the 1st, 2012, an 18-year-old financial services firm began a test run of their new trading software. It was carefully configured to interact with a very small number of stocks and buy and sell points right outside the normal range so that it wouldn't cause too much blast radius if it all went wrong. But 45 minutes later, the updated software had sent millions of orders, generating 4 million executions in 154 stocks for more than 397 million shares. It caused a $440 million cash loss for the company that nearly bankrupted them overnight, and actually they had to sell less than a year later, all because of a bug in the software. So we're all familiar with these type of scenarios. And computers do what they're told. You've heard the saying, garbage in, garbage out. And another person here from Gartner has said, if they're told to do the wrong thing, they're going to do it, and they're going to do it really, really well. Now, we will have questions and answers if you want to talk about this, so you can enter the questions and answers as you go along, but we will answer them right at the end. So feel free to start typing in questions, and Dove later on will ask me them. Dove is the guy who's coordinating this all behind the scenes. So how will you respond? Notice the word there, respond, not react, because the way to work is these things are going to go wrong. They always will do. So you need to have a response plan rather than running around with your head chopped off like a chicken. So what we're going to talk about today is building a minimum viable incident response plan. And we talk about minimum viable in this sense, just like we talk about minimum viable software, because with software, startups have got the idea that you don't do everything all at once. You build it up step by step. It's no difference to a response plan because it's not too big to start. And this is what many startups do. They don't put together a plan because I'm used to firms where they've worked in big corporates and there's hundreds of pages of documentation. They say, I can't do that. So they leave it alone. So I'm going to tell you how to get going on a little bit better way than just ignoring it, because putting your head in the sand doesn't work when things go wrong. First thing we need to understand is that systems are complex. Some people start from the assumption, well, I'm going to write such good software that disaster can't strike. There's mathematical modeling which shows that's actually not true, and it's not possible anymore. With the amount of complexity you've got in modern systems, you can't make things totally safe. There's always going to be a risk, so you need to have a response. Even in things like aviation, you've got two computers at once running totally independent code bases, but the pilots are still trained to how to respond if they both go wrong. So failure is unavoidable. So I would advise having a look at Richard Cook's book on how complex systems fail. If you are interested in that theoretical side of things, it explains it in more detail. And as we talked about, some think control and process can prevent incidents, but they can't. And so what we've got to do is start from that thing. Incidents aren't deviations from some idyllic norm. They are the norm. This is a quote from Rob England. So we look at the human factors and system safety. We've already talked a bit about reacting versus responding, and again, we'll go into the details of this now. So resiliency. So what you've got here is a hierarchy of looking at it all and approaching this. So I'll step through the different parts here. You start at the base level and work upwards towards it. Most people think, all we got to do is a bit of monitoring and we're fine. And that is the base level. So I would say put in all the monitoring, and I'm going to talk through these things as we go through it, many of these steps. But you put in that monitoring, and then you layer an incident response plan there. And then people think, hey, I've got somebody on call. that's job done. But is it though? Because then you need the post-mortem or root cause analysis. You need to actually work out when the thing did break, why did it break, and then you can make the improvements for the next time. You're looking into feeding into your testing and release procedures, because in many times, bugs have been caused from, well, most of the time actually, it's been shown that bugs come from new releases. And this is where you look at how you do release procedures and rollback. Capacity planning is the next layer on top. Always making sure you have enough capacity, then altering your development practices as needed, and finally your product, thinking about your product design and how it interacts into this. So you go through each of these individual steps. So incident, starting there. Life cycle of an incident. First step is detection. So we want to pick it up at the first phase of an incident. Your tooling has identified a problem. Notification has been triggered. So we'll look into this and there. Now, first step here, response, notification acknowledged. People have a few words on this because people often forget about this step. They forget about realizing you've actually got to handle it. It's not just sending out an email. You need to have an acknowledged one, because you've probably all been there in systems that have generated lots of emails, and what soon happens is a couple of things. One, people ignore it because it seems like spam to them. Two, they mightn't even be at the computer, so you don't know if anybody's picked it up or not. So you need a system where you actually have something acknowledged, and if somebody doesn't acknowledge it, then you can go to the next tier. You need to have an engineer explicitly on call. Startups sometimes forget about this, even big firms sometimes forget about this. You need to set the expectations for your on-call engineers very clearly. What is it that you need them to do? Do they need to respond within 20 minutes? Are they allowed to have a drink at all? Or do they have to remain totally sober? You might say that's a silly question, but it differs a lot. For example, like a safety critical system, there's absolutely no way that the person on call should be having any form of alcohol. They shouldn't be sleep deprived. They should be able to respond quickly, versus say a small consumer app where it might be okay. You might say the person's not allowed to be drunk, but they're allowed to, as long as they're under the legal drinking limit for driving, say, then they're all right to respond on call as well. So you need to explicitly put this into what you're doing with the engineers, so you know that they're going to respond in the right way and that they know that they're on call. And it is, like, for example, how far are they allowed to be away from home? Can they go to the shop, and as long as they're going to be back in 10 minutes? Or are they expected to respond in 5 minutes, half an hour, 2 hours? What is the on-call expectations? And during this response phase, you're troubleshooting, querying, diagnosing, and triaging, because you're trying to, first of all, work out what's actually going on and what's going wrong. So you formulate theories around remediation steps. And I'd say here, one thing that we're all really quick to do is to rush in to fix things. We see, the server's overloaded, so we'll go and reboot it, or we'll go and add an extra server to the pool. But do we actually really know that that's actually the case? So I'm not saying we should slow down how we respond necessarily, but we should actually formulate theories. And if it's a bigger type incident, then bring other people in and discuss it with them, so that you're looking at what happens if I do this. Will that fix the problem? Do we think, will it not fix the problem? Stop and work through it in a methodical way. It's the same way that, like an airline pilot, when there's issues, they work through checklists. They don't just sort of randomly start throwing the plane around in the air. It's, you need to say, we think this has gone wrong. You verify it by this. This is the response to it. So remediation. We're taking action. And I'd say here, make sure you're recording the actions taken in some form of log as well, so you can go back and analyze. You can analyze it afterwards, find out what was the proper causes of what went wrong, but B, when you've got multiple people troubleshooting, or if you're tired or whatever, you can actually record what you did and you say, well, when we did this, we do that. And it's a very simple thing. Always timestamp things, Don't just scribble down notes randomly. Put down the time that you did things so you can correlate it with later on with what went on. And then hopefully we get to service restoration from taking the actions here. So analysis. This is what we said before. We want to, we're recording things. We want to have a retrospective discussion of the timeline. And we talk about analysis here. I've deliberately removed the word root cause out of the analysis here. And the reason I've done this is a lot of people talk about root cause analysis because they assume that one thing went wrong and one thing caused the problem. And if you look at it very simply, you can say, well, yes, one thing went wrong, the server crashed, but you're not looking truly at what the real causes are, because the server might have crashed because of the inputs to the server. It might have been a bad code to the program which caused the CPU to max out. And you say, okay, we've actually solved the problem because the input was bad. But then, why was the input bad? Why didn't it, even if it was bad, why didn't it scale out automatically? Because if you're going to peak on CPU for a bit because of some bad code, you can get around it at times by having multiple servers scale out. So, when you're discussing the timeline, don't just go and look for that one thing that went wrong. Look for the factors and keep diving deeper and deeper. Keep looking at the other things going on at the same time. It might have been that you set, you had said that the servers could scale, but you set a limit of 20 as a maximum, and you needed more, for example, and you hadn't updated that, and you should look at that. You hadn't updated your limits of how many you could scale to. Look for opportunities for actionable improvement. I went into one job, I won't say where it was, but in the first week I had, where I led the infrastructure team, there was 20 severity 1 or severity 2 incidents that basically were causing production outages or massive slowdowns. And at the end of my first week, I said, boy, that was a bad week. And I said, boy, that was a bad week. And they said, no, that's actually a normal week. And you actually handled it really well for the first week. We got on top of most of that instance. And I says, this is a normal week. Shouldn't you be fixing it? And they says, we don't have time to fix all these problems. We know what we've done is developed a really good system to fix them and get things back working again. Needless to say, I soon changed that because that's not what you want to do. You don't want to get into a pattern of constantly fighting. Airline pilots, I keep on coming back to them, but airline pilots, they don't constantly plan for the plane to go wrong. They plan for the rare occasion when the plane goes wrong. So you want to keep on working on how to improve things. You want to keep on having deeper learning of how the system actually works, because to actually look at how you improve the system, we actually need to understand how it actually works, how all the parts tie together. And one of the key things that I find here is system documentation. Now, I don't mean necessarily a whole lot of Word or Google Docs here. They're really deep and complex. What I mean here, in most cases, what I find really works well is just having a wiki of some kind. It might be a wiki in GitHub, or it might be a wiki in Atlassian, or whatever your tooling is. But just have a simple one and keep building it up and up each time, and work on that, and get your developers and your infrastructure, DevOps people getting into the mindset as they adjust things, that they go and update the understanding. And then we'll get onto drills at a moment, but they're a good way to understand how things actually work as well. So readiness. You want to get to the state of less unknown unknowns. I think this was Henry Kissinger who talked about having the unknown knowns. He talked about the quadrant of things. You know your known known problems, you know about them, you can deal with, but you want to get away from the ones that totally blindside you. You want to keep on improving so you've got less of these problems that strike you just totally blind. Keep on learning and improving. We touched on this before. You want to keep training your people. You want to keep improving your technology, your processes. implement work. You might say, well, this is pretty obvious. It's not actually. It's one of the things that people often do is that they go and have an incident, they write it up, where they've had a problem, they say, these are the 5 things we need to fix. And if I had $1 for every time that I've walked into a company and said, okay, show me those fixes for those 5 things that you found in the incident, or show me the last 50 problems you found out of the last 10 incidents, the amount of times I've never actually gone and been fixed just astounds me. You need to go and create a work item. I know that within one of the divisions at Microsoft, what we have as a policy is that everything that is flagged as a severity 1 or 2 action must be fixed within 2 sprints before, when we log an action out of an incident. So we have to go and get that working and fixed immediately, basically, if we've worked out that's fallen into causing a problem. So how can we shorten each phase of a problem or an incident? First thing is to measure and to get your metrics. And these are some industry standard times. It doesn't mean that this will necessarily apply to yours. But until you actually start measuring, you can't actually work out how to respond. If you're taking, say, an hour and 10 minutes to work out that there's a system problem, then you need to work out on improving that first. If that's your biggest timeline, because there might be that you don't have good instrumentation or good observability on your systems. You don't want to be in the system, so you don't want to be in the place where your customers are notifying you before you know. If you've got all your customers ringing you angrily or writing bad things about you on social media before you even know, that's not a good place to be. Response. You put the on-call plans in place. Is that actually people responding quickly? Is it responding within the time that you expect? Remediation. How long is it to actually taking you to fix the problem? And I used the word remediation a couple of times. Remediation is about the time to restore service. And I didn't talk about this earlier where I probably should have. What you want to focus, us as systems type people or developer type people, we want the underlying problems to be totally fixed, but we need to think about it from a customer point of view, because a customer wants to be able to get working again. So it's more important to get it remediated than to totally understand and to totally fix everything perfectly. So monitoring. And it's often called observability these days as well. So here are some of the common tools that you can use. You've got open source ones such as Prometheus and Grafana. They're quite common. Prometheus has probably got the largest footprint in startups I've seen these days. It's a very popular open source tool. And you can chain these things together. They're not an either or nor tool. For example, people use Splunk for logging, for example. Azure monitoring will plug into Prometheus. It can scrape Prometheus metrics. So you can tie it all together. And but the important thing is that you need to have some tooling around there to collect the data, to collect the logs, etc. So your response plan. Having some tools. The most popular tool probably these days is PagerDuty. Most startups that I've seen or have worked in have used that. It is actually very good at what it does, which is it has one thing to do. The name implies it's like the pages of old, where if you're old enough to remember, people used to wear pages on their belt and it would beep and wake you up. And this is what basically PagerDuty does. It basically, your phone makes a racket, whether it's day or night, and it will wake you up. If you don't respond, then it will send it to the next person in the chain and it will keep going. And it does that well. It's very easy to set up on-call rotas. There's a number of other tools out there as well, but that's a good one to start off with. Azure monitoring can do things like SMS, phone paging, etc., but it's not as explicitly designed to be a full alerting tool in that regards, and you'd link it into the other tool. So you'd feed the monitoring in there, and the same with using AWS or Google, they will feed into PagerDuty. So I know, for example, that the AWS alarming feeds very well into PagerDuty, for example. On-call rotations. So we'll go through the different kinds. Standard one is just everybody's pretty aware of a 24/7, and this is when you'll start, typically you'll put people on, 8 hours a day, or depending on the size of the company, you might do it 12 hours a day, and then you just rotate it. And that's fairly normal, and somebody might do a week of 8 hours a day. So yeah, it's a good starting point. But then as you get bigger and you go globally, one thing I'm a great fan of is follow the sun. And what we call follow the sun is you put the person whose working day or daytime it is, you put that country on call. So if you've got an office in Asia, you've got an office in Europe, you've got an office in America, basically you can cover the whole day without waking people up. You might have backups of waking people up, but it's much, much easier if somebody can do it in their daytime. It means they're not sleep deprived. It means that, they can do it. They're probably already at their desk. Your response time, instead of being 15, 20 minutes, is going to be 1 or 2 minutes, because they can respond straight away if they're sitting there at their desk. It deals with multiple shifts, great for distributed teams, on-call during office hours, I mentioned. So custom, and then you may have some specialized needs. So you need to think about this. What some companies will do, for example, is that they'll have a follow the sun type operation for Monday to Friday, but then weekend coverage will be somebody different, because it might be that you split that up and do that differently. Who was on call? This might seem a silly question, because you just set up the rotor and you forget about it, but you want to make it visible in your system so that one person who is on call for one part of the system can talk to another person. Like if they are working on the database, they need to talk to somebody on the web tier, and you have split that in half. The person, it might be a bigger company now, it might be the person doesn't have the skills for both. You want to be able to look that up quite easily. You want to be able to have ways of generating an on-call thing. Like if you're a person in the company, you want to have a way to generate it if you notice something's gone wrong with the system, particularly in the early days when you mightn't have full monitoring or instrumentation for everything. So you might notice it as a person at the company before somebody else, or somebody might notice it on social media, for example, and you detect it. So you want to look at who's a primary person, who's a secondary person. If at all possible, you really do want a secondary person. Somebody mightn't wake up in the middle of the night. Somebody might fall ill and not tell anybody. They might just be, sometimes you get staff members who aren't as good as what they could be, and they ignore the pager. So you need somebody who's secondary on call. You want an incident commander, particularly as you grow, because one of the things that you find is that if you've got multiple people working on a problem, and multiple people aware of a problem, you're going to start to get into a state of chaos. A couple of things happen, that you've got people who are fighting each other for what should be done, and then the other side is that management is trying to talk to all the people who are trying to fix it, which actually is slowing down the problem actually being fixed. So you want to have that person sitting in the middle, and you may actually even split that role as you get bigger in half, because you might have one person talking to the engineers and one person talking to the management. And the simplest way to control it, in many ways, you can buy all these fancy systems, but what I've used consistently over time is either a Microsoft Word doc or a Google Doc, just for everybody to type notes into, is by far the simplest way. And you're not going to just have a blank Word document. You'll have a custom template that says, a whole lot of things. What time did the incident start? What time did the incident finish? Who's working on it? Chronological timeline. Things that need investigating further. and also then for later on, the analysis of the root causes, the many things that went wrong, and things like that, and their follow-up actions. Escalation paths, have these defined out as well. You've got your primary and your secondary on call, but have an escalation path. For example, say the system's running slow, and you know that you think that it needs a reboot, but if you do a reboot, you're going to knock out your web service to all the customers, and you don't feel comfortable to make that decision. Who do you ask to do that? Is it worth having a slowed down system versus no system that might come up quickly? You need somebody to have the escalation path. Or it might be you need a technical expert, somebody who's not on call, but for example, somebody knows that that Cassandra database really, really well, and you want to be able to look them up. So you need to have the escalation path to find and who can help out with different decisions, whether it's business or technical. Alerting. So we talked about that a bit before, so I won't go deep into that. Context. You need to understand the context of what's going on. It's rotation, and I skipped over this slide a bit too quickly. I thought that's going to be a follow-on slide. So one thing here that's useful to know is that we talked earlier about not rushing into things, building theories. This is where having context is quite useful. What you want to have is dashboards around the place. So when one part of a system is running slow, you understand what is contributing to it. For example, you might find, for example, that another system that has either been consumed or feeding into it has got a slow response time. So that's causing a queue to build up within your system that you think is a problem, but is actually just a symptom of the other one causing it. It might be that you've had, you ran a marketing campaign, you had massive customer demand, so you can see in another system, the web front end getting hit, and that's causing your middle system to be overloaded. So do go and look at the context carefully. Rotation and handoffs. One thing, people get tired. You need to have, if an incident starts to go on for hours, you might want to hand over to somebody else. You look at, how you're doing it. People think, well, I'm on this 8-hour rota, I'm on call for 8 hours, so I need to go to the end of my 8 hours. It is very draining working on a major problem. There is often nothing wrong, assuming you've got other people who can work on the problem, to say, hey, can we draw in somebody else here so I can have a little break? I need an hour's break just to refresh my mind or doing it, and then I'll come back on. So look at that, to have handoff, to have rotation, because it is hard work. And as part of that, you'll make sure you do a debriefing though as you hand over. Take 5 minutes to explain to the person that you're handing over to, what's going on. Or if you have got to the end of your shift and you are handing over to a new person, that you do debrief properly. Take that time to overlap. Game day exercises. So these are really important to prepare. Coming back to the pilots, my analogies here, they have flight simulators. There's a reason for it. They practice and practice and practice so that they know what things can go wrong and so they can prepare for it. So I strongly encourage you to do this with your with your test systems or your disaster recovery type systems or dev systems. Prepare and do practice runs so that you can know how to respond and what to do. So then you can prioritize failure, look at that and understand that. Then what you'll do is, and there's things here, how you do this is do things, if you Google Chaos Monkey, there's systems that randomly cause problems, for example, or you could get another one of your team to go and deliberately take down a system, but you can have ways to do that. And then you can see, did our system detect it? So go and, for example, inject 10 times the normal load, or go and deliberately slow down a system. So instead of responding in 5 milliseconds, it responds in 200 milliseconds and doesn't cause a problem. Do you actually even notice it that it has deteriorated? So in this preparation phase, you want to see what you can observe, and then you can go and instrument more. So, then we can go and create, as a part of our preparations, create the on-call rosters. Remember to do your primary, secondary, your incident commander. Then, with doing this practicing, you can also make sure that you've got contextual, actionable alerting. The amount of times that I've seen and experienced myself, initially you get page that says severity 1 incident on database server, and you're thinking, what does that actually mean? Does it mean that I've got an overload in CPU, run out of disk space? What does that mean? And more than that, you want it to be as much detail as you can, so you can understand what you need to do about it, because like you want to have things like saying, CPU overloaded, reach the maximum size of the virtual machine scale set. So that, hey, okay, an immediate action I can take is to scale up the system even more, extend those parameters as a workaround to get going potentially, if that's the thing to help solve it. As I said before, prepare those escalation paths. Look through all the parts of your architecture and put those all in place. Make this a routine. To do the preparation and the test, to prepare the handoffs in advance, practice. So, to go back to the aviation industry right now in the COVID-19 times, what we're seeing is that you see all these ghost flights, because people, if they don't have access to a flight simulator, there are limited flight simulators around the world. What they do is they go and fly their planes every 45 days, I should say, to keep their certification. It shouldn't be any different to your system type tests. You should be doing it, say, tests every month, 2 months, 3 months, because systems change. Planes don't change all the time, but systems definitely do change. B, people forget things. When you're doing an incident, you might have forgotten what could go wrong. The other thing, you might discover new things, so keep practicing and practicing. Keep improving. You have that catalogue of things that come out of previous incidents. Go and implement those. Add them to your backlog of tasks that you go through in your sprint planning. Also, when you're doing your practicing, you'll think, hey, we could have responded more quickly if we had this or this and this in the system. And so go and do that. And I'd encourage you to, on this improvement side, go look at the Google SRE book, for example. They've written some very good material about how to practice, how to improve your systems. So we're getting near the end here. Here's a link to some of the things that we talked about, some of the ones like the Night Capital story at the beginning, how I talk about complex systems fail. We talked about control and how you can't control everything, and a good one called Shit Happens. Now, I can send out afterwards, if you ping me either on email, which I'll put up my email details later, or on LinkedIn or Twitter. If people want to see all the slides, then I can definitely send them out to you. So we'll be moving on to the question and answer shortly. But so thank you very much for listening to me today. As I said at the beginning, my social handles are imcdnzl, and my email address is ian.mcdonald@microsoft.com. And if you want to know more about Microsoft for startups, have a look at startups.microsoft.com, or look for us in LinkedIn or on Twitter. So one of the things that we like to do is to see if these sessions really add value, and which sessions people like and which sessions people like less, so that we can have more and better sessions. So I'd encourage you, please, after you've done this, go to aka.ms/reactor/survey, and then take that event code 7680 and put it in there, so you can say whether you think I did a good job or not. And tell me how I can improve so that we can give better events for you. You can also join our community. The London one here is the details. You can search on Meetup for Microsoft Reactor London. We have many of these worldwide. You may be dialing in from other parts of the world. We have a YouTube channel as well where where many videos go on as well, and you can sign up for for emails about future events. Now again, if you forget all these, just email me or ping me on social media and I can send this out to you. So questions and answers. Love, I'll hand over to you to read these out if there are any.
Amazing. Thank you so much, Ian, for this session. We have a few questions here in the Q&A section, and I think we can start with a quite early question, which was about the pyramid you showed in the sort of beginning of the session. Do you know which one I mean?
Yes, I do, and I'm having a look at the Q&A here. I don't know that name of the pyramid. Hang on, I have some briefing notes because I didn't originally write this deck. I've altered it quite a bit myself, but I'm just seeing if the notes here talk about what it's actually called. No, it doesn't actually. So I will try and find out from the person who wrote that slide and see if they can tell me of it. I saw there's a follow-on part to it. Is any of this freeware? All these slides are public domain. Yes, so yeah, if you want to take any of this material yourself, that is absolutely fine.
Amazing. And then you sort of followed up already on the questions about slides. If we could get the slides later with the video. I think you will publish the slides on your social media, is that so?
Yeah.
And then the video we can follow up in the meetup group after the session is over. But basically you will use the same link as you used to join the live session right now. And in a few hours, maybe a day or so, you will instead reach the recordings.
Yep.
Moving on. And doesn't having a small response time compromise the correct response to a particular event management?
Okay, it may have been clarified a little bit as I went on. The response time is the time for a person to answer the pager, basically. So you want that to be as short as possible because that should be automated. You don't necessarily want the remediation time your comment will be more applicable for because you want to make sure you remediate it properly. But the response, the paging should always be automatic. It should always, it's not a person deciding who to page generally. So I would say that should be as quick as possible because it should be automatic. But of course, you can't tell somebody to sit, by their computer and wait 24/7 for something to go off. So it's not going to be 30 seconds generally, unless you have unless you're a very large corporation like a bank, for example, that may have people sitting in the office waiting for things to happen.
Awesome. And I think the last question was about your social media links, and I saw you already published your handles there in the chat. And that I think is it. Wait. Hamad Somro, who asked about the small response time we just spoke about, is asking for link. Can you, Hamad, clarify what link you're looking for?
I will put on if you contact me on Twitter or LinkedIn or email, and I'll put my email, I will send links to this document. Or if I'm not understanding the question properly, then you can ask me the question again via email or social media.
Perfect. I think that's it for the Q&A then.
Okay, thank you very much for attending and listening, everybody. We will now wrap up. So thank you very much.